Assalamualaikum girls. Today we are going to see chapter number 7 in network 2, that is a congestion control and quality of a service. Here it is written chapter number 24, that is actually belongs to the textbook, right? Actually this chapter is of chapter 7 according to our specification. Okay, chapter 7 name is congestion control and quality of a service. So move to the next slide. See here, the first slide, quality of a service. Simply we can say QoS in a short form. Quality of a service is an internetworking issue that has been discussed more than it defined. It's a network issue here. How the quality of a service, how we are providing the quality when we are transferring the data or when you are using a network, how we are providing security or anything. Everything is nothing but a service. So how we are providing the quality of a service is the this chapter. Okay, we can informally define quality of a service as something flow seeks to attain. What is the quality of a service and how it is explained, that we will see. So topics which we are going to discuss in this section are flow characteristics as well as a flow classes. What are these things, we will see in the next slide. See here in this slide we are going to see what are the flow characteristics. Okay, here there are four flow characteristics which are available, that is reliability, delay, jitter as well as bandwidth. Here actually these four characteristics we already saw in network 1. We finished in very first chapter itself. These four characteristics will you can see there in network 1. So today we are going to discuss again. The reliability means what here it is available is a characteristic that a flow needs. A lack of reliability means losing a packet or an acknowledgement, which entails a retransmission. If the packet is losing, then we need to go for retransmission, transmission the packet again. Just we will see what is reliability in detail. A reliable protocol provides notifications to the sender as the delivery of a transmitted packet. When the sender is sending the data to the receiver, then the reliable protocol will send a notification to the sender that yes, your packet is received by the receiver successfully and your packet is reached successfully. That is a notification. That is a notification which is sent by the reliable protocol to the sender. Yes, your packet is received, as opposed to the unreliable protocol. So when unreliable protocol does not provide the assurance of a delivery of a packets, the packets have delivered or no, the unreliable protocol that cannot be send any notification to either sender or the receiver. Okay, here reliability is we can say it's a synonym of assurance. Okay, one of the other name of reliability we can say that is assurance. See here, when you are sending the packet to the sender to receiver A to B, okay, once the packet is when the packet is sent by the sender and received by the receiver B, so the reliable protocol will give the notification and give a small message that is yes, your packet is received. That is known as acknowledgement. The reliable protocol it will take the responsibility of both a packet as well as acknowledgement also. Okay, that is called reliability. And coming to delay, the second flow characteristic is delay. Here it is a source to destination. Delay is another flow characteristic. It is there, but actually we will see in detail what is a delay here. Here nothing but network delay. It refers to the amount of a time it takes for a packet to go from A to B. You understand how much time it will take to transfer a packet from A to B is known as a delay. There are many types of delays which are available in a packet switch network. I'm talking about completely packet switch network. So there are some delays which are available, classified into some four types. Okay, that is a propagation delay, transmission delay, queuing delay as well as a processing delay. So we will see in detail what are these things. See here, dear, whatever I am explaining now, that is not available in the slide, so please make a note of it. Okay, so what is the first one? That is a propagation delay. What is the propagation delay means? It means time takes for a bit to reach from one end to other end of a same link is known as a propagation delay. You understand? the time takes to transfer a bit from one point to the other point in a link is known as propagation delay. Coming to the second delay, that is a transmission delay. It refers to the time takes to transmit the data packet onto the outgoing link is known as a transmission delay. How the packet is transferring means what time it takes to transfer a packet on outgoing network is known as a transmission delay. And coming to the queuing delay, that refers to the time that packet wait to be processed in the buffer of a switch. For example, A to B, we want to transfer the data. There is a communication link which is available in A to B. In between, there is a switch in between sender and receiver. Then, and the queuing delay, what is the meaning of queuing delay? Means whatever the packet you have sent to the receiver side, how much time it is waiting at the buffer of a switch, that is known as a queuing delay. Okay, what is the queuing? What is a queue that we will see in this chapter next slides. Okay, and last, coming to the last, processing delay. Okay, the processing delay, any time takes by a switch to process the packet header. That is, it totally depends on the processing speed of a switch, we can say. You understand? See here, queuing delay, how much the packet is waiting at the buffer of a switch, and processing delay means how much time the switch is taken to transfer the packet to the receiver side. Okay, so these are all the four types of delays which are available, especially categorized in packet switched network. Okay, this is a delay. And coming to jitter, here jitter is nothing but it is a here in the slide which is available, jitter is a variation in delay for packets belongs to the same flow. Okay, means jitter is nothing but it's a variance in time delay in milliseconds here. It's a very small amount of a time, that is delay in milliseconds between the data packets over the network. The technical term for the jitter that we can also known as a packet delay variance. You understand? Means how what time the each packet, one packet to other packet. For example, I want to transfer the data to the receiver side, A to B. I want to transfer the data. I'm a sender and someone is a receiver. Okay, the complete data is divided into some number of packets. Okay, that we have already discussed in our lecture. So that is a packet switch network. So all the data is divided into packets. So each packet, how much time it is taking for each packet to transfer with the same flow. 10 packets we are transferring. How much time it is taking to transfer the packet number 1 to packet number 2? How much time difference is, the variance in time is known as a jitter. Okay, and here we can say what is then delay is also transmission, I mean variant in transmission. Jitter is also, we are taking a variance in transmission. So what is the difference between delay and jitter? This actually, the delay and jitter both are linked by nature. Okay, and but both are not same. Fine, they are linked in nature but both are not same. What is delay means? Again, it is time taken for a data to move from one end to other end on the network is a delay. And what is the jitter? Jitter means, in other hand, the jitter is a difference of a delay in between two packets. You understand? One point to other point, moving the data from one end to other end over a network is a delay. And in the same flow, how much time it is taking from one between two packets, what is the difference in time is known as a jitter. Okay, and coming to the last flow characteristic, it is a bandwidth. Different application need different bandwidth. Actually, what is a bandwidth means? There is a easy to understand definition. I will tell you what is a bandwidth means. It is the boundaries of a frequency, we can say. Frequency means when you are transferring the data in the form of an analog form, the wave format of a data you are transferring. A simple wave, what is the meaning of wave? Yani the voice, I am talking, you people are listening. How it is possible when we are in a classroom, I am talking and you are listening, and you are talking, I am listening? How it is possible? What is the medium between you and me? There is a air is a medium. So whatever the sound which is coming from my mouth, those waves are traveling over air and they are reached to the destination. What is the destination? Your ear is the destination. So this is the bandwidth, that is nothing but called boundaries of a frequency. When air is a medium to transfer the analogous signals, or we can say the frequency to transfer the data. So air is a free to accept all the analogous signals, right? So when you are transferring the signals from one end to other end, A to B, some other sender and the receiver also transferring the data using the same medium as a air. Yes or no? So both the signals will be collide each other. So for that reason, we are fixing some bandwidth. In this boundary only, the analog signals are transferred from A to B. In this boundary only, the analog signals or the frequency are transferring from C to D. When two or more senders and receivers which are available, and using air as a medium to transfer, so bandwidth is a compulsory thing. When simple, when you are, I'll give an example like flights. Okay, from Abha to Jeddah there is a flight which is available. So only one flight which is flying on air, on sky? No. Answer is no. So there are many flights which are traveling at the same time, maybe to the same sender to the receiver, or maybe different sender to different receiver, using the same sky as the medium. So how it is possible without colliding one flight to the other flight? For example, see Abha to Jeddah, one flight, the flight is traveling at 10 a.m. At the same time, Abha to Riyadh also having one more flight at the same time, 10 a.m. for example. Okay, and both are using the same medium as a sky is the medium. So how they are not colliding each other? How they are not, being accident each other, just because of the bandwidth? We are fixing the bandwidth from sender to receiver. Here, sender is Abha, we can say, and receiver is Jeddah, we can say. So sender to receiver, we are fixing the boundary to the flight. Okay, within that boundary only the flight must move from one sender to the receiver. So that is known as a bandwidth, is also known as the boundaries of a frequency. Okay, hope you understand. Next, move to the next slide. See, flow classes. Here the flow classes, based on the flow characteristics, we can classify a flow into groups, with each group having a similar levels of a characteristics. This categorization is not formal or universal. Okay, it is not fixed to flow. There are different flows which are available. So what are the flows and what are the flow classes and what are the flow characteristics, we will see in the next slide. Okay. See here, techniques to improve quality of a service. So how to improve the quality of a service? See here, in this section we discuss some techniques that can be used to improve the quality of a service. So what are the methods here? There are four methods we discuss here. One is called scheduling, traffic shaping, admission control, as well as resource reservation. So these are all the four characteristics, or we can say four common methods to improve quality of a service, QoS. Okay, what is the four characteristics or the four methods? That is the scheduling, traffic shaping, resource reservation, as well as admission control. Okay. See here, what is the first method? That is called scheduling. What is scheduling? Packets from different flow arrives a switch or a router for processing. A good scheduling technique treats the different flow in a fair and appropriate manner. So when sender to receiver, there is a link between sender to receiver, and in between the two end points, there is a switch in between. There is a connector switch in between, or we can say router in between for the processing your packets from one end to the other end. So at the point of a switch or at the point of a router, we are applying some scheduling technique. How the flow of a data to be, how fair it is, means equally distribute or equal time you have to give for each packet to transfer. Okay, that is a flow, we can say. Here several scheduling techniques are designed to improve the quality of a service. We discussed three of them here. There are many techniques to improve the quality of a service. What are the three things we are going to discuss here? FIFO queuing, that is a first in first out queuing, priority queuing, and weighted fair queuing. These are all the what we can say methods to improve quality of a service. What is a FIFO? What is a priority queuing? What is a weighted fair queuing? We will see in the next slides. But this is one of the important concept here. Okay, if exams are there, then these three are the important questions I may ask you, like what is a FIFO queuing, or what is a priority, and what is a weighted fair queuing, or what is the difference between these three methods. These type of questions may be asked in the exam. Okay. See, here coming to here, that is a FIFO queuing. FIFO, first in first out, all of you know, that is a packets wait in a buffer. Okay, buffer is nothing but a queue over here. Okay, until the node means router or a switch in between, okay, is ready to process them. As I discussed in the before slide, when A and B are the two endpoints to transfer the data, in between A and B there is a switch is available, or there is a router is available. So at the point of a router or at the point of a switch, we are applying some techniques. That first technique we are applying is a FIFO queuing. Okay, how the switch as well as the router are processing the packets from one end to the other end. If the average arrival rate is higher than the average processing rate, the queue will fill up and new packets will be discarded. See here in the diagram, there is a queue. Here in a diamond shape, there is that is nothing but a condition. At the blue here, it is a capsule form, it is a processor. So we are checking when the packets is receiving to the router or a switch, we are checking whether the queue is full. If no, transfer the packet to the queue. If the queue is full, yes, so discard the packet. Any new packets we are not allowing. Why? Because queue is full, so there is no chance to add one more packet to the queue. So discard and delete those packets. So what happened here, when the queue is free, the packets are taken by the switch or the router, and after taking one after other, which is comes first, that will be served first, and that will be processed first. That is a concept of FIFO queue. First in, first out. First in packet into the queue, that will be processed first. Yani departure. What is the meaning of departure? Sending to the other point. Fine. So coming to here, second type of a method, that is a priority queuing. What is the meaning of priority? There are two types of priorities we can say. One is a highest priority and lowest priority. Simple words we can say what is a priority means: important data and unimportant data we can say. Okay. See here in a priority queuing, the packets are first assigned to the priority classes. Whatever the packets what I'm sending from A to B, for example 10 packets I'm sending from A to B, all those 10 packets not that much important, means each packet is having some priority. So packet number 1 is having more priority, and that packet must be reached to the destination at any cost, as well as that reached to the destination to the first preference. Okay, so what we are doing here in priority queuing, complete what packets, how many packets you are sending, all complete packets we are dividing into queues. That is priority queue, highest priority to the lowest priority. See here in the second point in the slide, the packets in the highest priority queue are processed first, because those are all very important data which is available in that packet. Coming to the third point, packets in the lowest priority queue processed last. Okay, here and see here in the diagram, there are two conditions which are available. In the before slide FIFO, there is only one queue. Here two queues are available. One is for the higher priority queue, next one is a lower priority queue. So the classifier here in yellow, okay, that yellow part is a classifier that will classify, yani that will divide the complete number of packets into two queues. That is highest priority packets as well as the lowest priority packets. So very important data is the highest priority, and that much not important data will be come to the lowest priority. So all will be transferred to those queues respectively. If the queue is full, again same thing, queue is full, then don't accept the packet. If queue is not full, that is queue is empty, still can accept the packet, then accept the packets into the queue. Okay, and whatever the packet which reach first, that will be served first. Same like, see here when we are talking about each queue again, See, highest priority queue, according to this diagram, see here, highest priority queue, we are having 3 packets in highest priority queue. So which packet will be processed first? Again, we are taking the concept of FIFO only. Okay, in highest priority, again there are 3 packets are there. So which packet come first into that highest priority queue, that will be processed first. Same like here in the lowest priority queue also. Yani when you are talking about the priority queuing, of course we are dividing the complete queues into 2 parts. One is the highest priority and lowest priority queue. But in each queue, that may be highest or lowest priority, each queue again it is following the FIFO concept. You understand? And after that, processing from the highest priority will be processed first according to the diagram. See here, the switch turn to the other queue when the current one is empty. Any switch the processor when the highest priority queue is empty, then the switch will be go to the lowest priority queue and serve the packets which are available in the lowest priority queue. Understand? So this is known as a priority queuing. So when I will ask you a question like priority queuing is following FIFO, yes, the answer is yes. How? And when we are dividing the complete priority queuing into 2 queues, highest and lowest priority, when we go to each priority queue, that is highest priority queue, again it is following FIFO. Lowest priority queue, yes, again it is following FIFO. Okay. Coming to the weighted fair queuing, that is the third method. 3 methods we discuss. Okay, that is FIFO queuing, priority and weighted. Which is the best one? We can say this one is the best. Yani the better scheduling method is a weighted fair queuing. Previous method what we discussed, that is a priority queuing. There we have saw 2 queues, the highest priority as well as the lowest priority queue. So here we are dividing the complete data and complete packets into 3 parts, 3 queues we are. Highest priority, medium priority as well as the lowest priority, so that each packet have distributed in the correct way. So that's why we are calling this is a better scheduling technique. See here, the better scheduling technique method is a weighted fair queuing. In this technique, the packets are still assigned to different classes and admitted to the different queues. The queues, however, are weighted based on the priority of the queues. Highest means the highest weight, medium means the middle one, the lowest means the last queue. So all the packets are how many packets you are transferring from sender to receiver. The classifier is divided the complete number of packets into 3 queues, highest, middle and lowest priority. Same again, highest priority queue will be served first, then go for the medium priority queue and go for the last one, that is the lowest priority queue, and the processor will be depart all those packets from at the point of a switch or at the point of a router to the other end of the network, any destination. Clear? So this is called weighted fair queuing. And coming to the next topic here, that is a traffic shaping. Traffic shaping is a mechanism to control the amount and the rate of a traffic sent to the network. What is the traffic here? What is the meaning of a traffic? Here, general example or a general meaning of a traffic means all the cars are moving on the road. So when some accident or something happens, what happens? All the traffic will be jammed at one place. Excuse me. Here we are talking about traffic here. There is a traffic over a network also. Okay, that is how we are shaping the traffic, yani how we are maintaining the traffic. Traffic is what is the type of a traffic. Here, for example, here we are talking about a general terminology. What is the traffic means? The cars which are available on the road. So what are the things which are available on the network that we are talking about the traffic shaping here? That is the packets. Packets are transferring from one end to the other end. How the packets are transferring, how we are shaping those packets to transfer from one end to other end, that is nothing but a traffic shaping over here. So when we are talking about traffic shaping, there are 2 techniques which are available. One is called leaky bucket and next one is a token bucket. Leaky bucket algorithm shapes the bursty traffic into the fixed rate traffic by averaging the data rate. It may drop the packet if the bucket is full. See here, you know all of you what is a bucket. Okay, that bucket contains all the packets which we are fill into the bucket. And what we are doing, we are making some hole in the bucket. So but the data, or the data is coming at the same rate. Okay, that is known as a leaky bucket. We will detailedly see in the next slide what is a leaky bucket. And coming to the next technique, that is called token bucket. The token bucket allows the bursty traffic at the regulated maximum rate. So what is the token bucket, what is the leaky bucket, we will see in the next slide. Okay, so these two are a very important algorithms of chapter 7. What is a leaky bucket algorithm, what is a token bucket algorithm? See here, leaky bucket, you just see the diagram here. I will explain with the diagram, then you will just read it, then you can understand. See here, left side diagram, which is leaky bucket. Okay, the water which is available in the bucket, so we make a hole to the bottom of the bucket. So what happened, each drop the water will be fall drop by drop. And what we are doing over here, that is we are making the traffic into what we can say, that is in a correct flow. Okay, in exact flow, what we want to maintain the complete packets into a regular flow. Okay, so that is we are making here in a leaky bucket. So all the packets which are filled here, it is showing as a water. When we are talking about the network, all the bucket is filled with the packets. Okay, we are making the hole to the bucket. So one after other, the packets are releasing by the bucket, one after other, one after other. So what is the capacity of a bucket, you have to fill that one. If you want to give more packets into the bucket, what happened, that will be overflow. In the previous slide what we saw, that is when the bucket is full, you may lose your information, you may lose your packets. Clear? So coming to the next slide, please also explain about the leaky bucket only. Just move to the next slide, you will get a better idea of leaky bucket over there. See here, leaky bucket implementation. A simple leaky bucket implementation is shown in the figure. A FIFO queue holds the packets. Here also see the leaky bucket implementation, or it's maybe a priority queuing, or it is a weighted priority queuing. Every technique is implementing the FIFO only, first in first out. Okay, if the traffic consists of a fixed size packets, example cells in the ATM. What is a cell? Cell is also nothing but a packet here. Why we are calling a cell when we are talking about ATM network, asynchronous transfer mode networks, we are using a cell. Cell is nothing but a packet. But when we are talking about ATM, don't call it as a packet, it is a cell. The name is cell. So what is a cell again? Again, the cell contains two parts, same as we discussed in the lecture. That is, packet contains two parts. One is the data part, one is the header part. So same, cell is also contains two parts, data part as well as the header part. Serves as the same, but the terminology is different. Okay, see here, if the traffic consists of a fixed size packets, the process moves a fixed number of packets from the queue at each tick of the clock. So we are setting a clock over there. One tick, the queue is moved. Okay, yani the packet is moved from the queue to the switch or the router. From that, the packet will be departure. If the traffic consists of variable length packets, yani different length of each packet is a different length. Okay, then the fixed output rate must be based on the number of bytes or bits. See here, when we are talking about the leaky bucket, and talking about the leaky bucket, all packets of the fixed size packets are available. Then the flow is a consistent flow, we can say, and constant flow it is maintaining. Clear? So here, see, coming to the diagram, same queue we are maintaining. If the queue is full, don't allow the packets. If the queue is not full, it is empty, so send the packets into the queue. When we are fixing the clock over there, if the clock make one tick, means the packet will be moved from the queue to the processor. one more tick, then another packet is moved from queue to the processor. Then after processor, what the processor will do with the packet will be depart, yani send to the receiver. So this is how the leaky bucket algorithm or leaky bucket technique is we are applying to consistency of flow of a packets over a network. Okay. Coming here, the next technique, that is a token bucket. Okay, here also it is maintaining a bucket only, token bucket. So come to the slide. The token bucket can easily implemented with a counter. The token is initialized to 0. Each time the token is added, the counter is incremented by 1. Each time the unit of data is sent, the counter is decremented by 1. When the counter is 0, the host cannot send the data. I will explain each and every point clearly. See here, there is a bucket which is available. When each time the packet is added to the bucket, then we are maintaining a one counter over here. So when the packet is added, then counter is incremented. So where we are adding the packet? Simply to the queue. Here in the diagram there is a queue. We are adding the packet to the queue, the counter is incremented by 1. We are adding the second packet, again the counter is incremented by 2. Third packet, counter is incremented by 3. Like that, how many packets or how many tokens it is received or how many tokens it is given to the each packet until the queue is full. If the queue is full, don't allow any packets. Any queue is full, there is no chance to accept the means more information, right? So what happened here? Queue is full. Now each packet from the queue is processing from the switch or to the router to the other end point of the to the receiver. So here when the packets are available in the queue, so one packet is moved from the queue, then the counter is decremented. The second packet is moved, then again the counter is decremented. The third packet is moved, again the counter is decremented. Then how much time the counter is decremented? Until the counter becomes 0. You understand? Here in the token bucket, we are maintaining the counters at two parts here. When the packet is added to the queue, counter is incremented. When the packet is delivered from the queue to the other end, okay, from the point of a switch or the router to the other end, the counter is decremented. So each time the counter is incremented when the packet is added to the bucket, and each time the counter is decremented when the packet is depart from that point to the receiver point. So this is how the token bucket is implementing. So here in the diagram, see here there is a condition. The queue is full. Any packets are the packets are filled in the queue, means all the counters we are incrementing. Once the queue is full, don't allow the packet. The new packets will be discarded if the queue is full. If the queue is empty, of course you can allow the packets into the queue. So any counter is incremented. Now if the queue all the packets are received, any queue is full, for example, then what happened? One after other the packets will be depart, send to the other point. So when one packet is sent from the queue, then counter will be decremented. So which algorithm? Again indirectly we are following in the queue, again FIFO we are following. Okay, you may see here in a FIFO or in a priority queuing or weighted queuing, it may be a leaky bucket or it may be a token bucket. The names are and the processing is different, but indirectly we are applying the FIFO algorithm in each technique for the traffic shaping. Okay, so here also we are applying FIFO when the queue is full. So first in packet will be depart first. The first in, first out. The same thing we are applying here in the queue also, in the token bucket also. Okay, this is how we are implementing the token bucket. So move to the next slide. Here there are two important things that we are discussing over here, that is resource reservation as well as admission control. So flow of data needs resources such as buffers, memory, bandwidth, CPU time and so on. There are many resources are available here. A quality of service is improved if these resources are reserved beforehand. We discuss in this section one of the quality of service model called integrated services, which is heavily depends on the resource reservation to improve the quality of a service. See here, service means we are providing some service to transfer the data. Here, what is the complete service we are providing when you want to transfer the data from A to B? So what are all the things we require to transfer the packets from one end to the other end? We need two computers, any two systems, we need two hosts, we need, yeah, we are going to reserve A and B to transfer the data. Okay, that is one resource. And what we need a buffer, any memory. When we are having the packets which are holding at the sender system, we need a memory, and we are transferring the data to the receiver, and the receiver system capable enough to store the data which is coming from the other point. Yes or no? That memory also must be available at the receiver side. That is also one of the resource. And here bandwidth, how the data is transferring, which bandwidth, which boundary the data is transferring without any collisions or without any accident in between the air or in between the frequencies what we are using to transfer in the medium, right? So these are all the resources. We need the CPU time. So when you are transferring the data, we are reserving all the resources beforehand. Means when you are reserving all the resources before transferring the data, then you will not face any problem in further transmission. Okay, when you are going to transfer the data, before going to transfer the data, you need to reserve all the resources over here. Clear? So that is the resource reservation. When you reserve all these resources beforehand, that is a best service you can give for that transaction. This is resource reservation is one of the best criteria to improve the quality of a service over a network. Okay, here when we are talking about the resource reservation, here resource reservation is static. We are not using the resources by dynamic tier. Static means beforehand we are reserving all the resources when you are going to transfer the data. Clear? So that is known as the resource reservation. We can say resource reservation is good idea. Answer is yes. The resource reservation is a good idea, and we can say it's a best technique to improve the quality of a service. Clear? And coming to the next point here, the admission control. The admission control refers to the mechanism used by the router or a switch. Okay, what is a router? What is a switch? All of you know. And switch to accept or reject a flow based on the predefined parameters called flow specification. Before a router accepts a flow of a processing, it checks the flow specification to see if this capacity and capacity in terms of bandwidth, buffer size, CPU speed and everything, and previous commitments to the other flow can be handled the new flow or no. See here, admission control is nothing but, see, the mechanism which is available at the router part as well as the switch part, not at the sender and the receiver. You understand? A and B are transferring the data in between, so there is a link between A and B, and this admission control is available in between the 2 points, like at the point of a switch or at the point of a server, we are having this admission control. So when all the packets are we are sending, so I'm a sender, some is the receiver, A to B, A is the sender, B is the receiver, A is sending all those packets to the B. So what happened at the between the router capturing all the packets, any router is holding all the packets, it will check the parameters which are already specified, the flow specification it will check. Yes, it is, the flow specifications are clearly, like the bandwidth is there, yes of course, and the buffer size you have mentioned, what is the buffer size which is available at the sender as well as the receiver. These are all the specifications which is checked by the router or the switch. When all the conditions are satisfied, then the flow will be accepted, otherwise the flow will be rejected. Clear? So this is how admission control is handled at the side of a router or a switch. Coming to integrated service, see here before slide what we have discussed, that is resource reservation as well as resource reservation and admission control. Those belongs to actually this one, that is integrated services. Okay, two models have designed to provide the quality of a service in the internet, that is the integrated services as well as the differentiated services. So topics which we are going to see here, what are the flow specification, admissions and everything, it is briefly defined here. So as I discussed here, that is previous slide, just previous slide, that is the resource reservation as well as admission control belongs to this topic, that is integrated services. Okay. Integrated services, sometimes called as INSERV in a short form, is a flow-based quality of a service model designed for IP, which means that a user need to create a flow and kind of a virtual circuit from the source to the destination and inform to all the routers of the resource requirements. So integrated services, so whatever the services which we are providing to transfer the data from one sender to other receiver to improve our quality, and it is also part of the quality of a service. It is specially designed for IP addressing, which means the user need to create a flow. Okay, the flow must be in an order, a kind of a virtual circuit we can say, from source to destination, and inform to all the routers which are available in the path. So this is known as the integrated services. Here ends your chapter 7 dear.